All right, now let's go ahead and talk about some ellipses and circles. We're going to start off with our circles here. And we know that a circle is a round plane figure whose boundary, aka the circumference, consists of points equidistant from a fixed point, aka the center. And we should also note here, of course, that the distance between the circumference and the center is known as the radius of the circle. So hopefully these first two equations are a little bit of review from you from algebra. So we, of course, from geometry. These x squared plus y squared equals r squared. And of course, if we're going to move that circle around, we're going to use our values of h and k. So we now have x minus h squared plus y minus k squared equals to your radius squared, where we know that center is going to be at the point hk. All right, and as always, a reminder, you can look at that vertex form. We know that we're going to swap up our values, and anything with the x goes for the x value, and anything with the y goes for the y value. So starting here with example number 1, we're looking at our center and radius. So starting with our center, we're going to look at these points right here. So we know that our center is at the point negative square root 3, 1, and our radius is going to actually be, right, we know that our radius is going to be the square root of this number. So our radius here is square root 13. All right, pretty straightforward when you're just pulling out some of the information. Now let's actually graph it. So when we're graphing it, we want to find our center first. So we're going to find our center at the point negative 1, 2. And you can go ahead and graph that point, but make sure that you go back and erase it when need be. And our radius is going to be at the square root of 36, aka 6. And of course, radius is a distance, so it's going to be only our positive in this situation. All right, so we're going to go ahead and move out 6 in all of our directions here. So we're going to go over 6 to the right, over 6 to the left. We're going to go up 6, so 3, 4, 5, 6, and then also down 6. In this direction. And then the best that you can, of course, take your pencil and draw a circle. I'm going to hope that my iPad there we go, pops one in here for you. But of course, I'm not judging you a lot on that circle, but you can go ahead and do the best that you can. And then if you want to go back and kind of erase that center point, but of course that point is not on your circle or on your graph. That was just representing the center there. Maybe if you wanted to, you could actually maybe use like a highlighter just kind of or something to remind yourself of where that center might be. Okay, so that of course is graphing it using your equation, but from the graph, let's figure out the equation that we are going to use. So the things that we need is we need the center of the circle. So go ahead, you can find your center, and you can do that by looking at your kind of endpoints that you have here, right, and finding the middle of those. So our center is at the point, let's see, 4, negative 3, and then we also need our radius value. So we're going to go ahead from the center, head over to one of our endpoints, and because it's 2 boxes, but this is scaled by 1, our radius is 1. So our equation is going to be x minus 4 squared plus y plus 3 squared is equal to 1. And of course, one thing to note here is that 1 should be squared. I mean, it is squared. We know that 1 times 1 is also 1, but just as a reminder there is that whatever your radius value squared should go here. It just so happens that these two numbers are the same. All right, so that's pretty much all there is in terms of circles. So they're pretty straightforward, and hopefully you remember a lot from geometry. All right, now let's kind of look at our ellipses. And again, if you kind of remind yourself to go back to 7.1 and look at these different points here, is that, these different conic sections, we also have an ellipse. So the ellipse is the set of all points in a plane such that the sum of the distance from the two foci at any point on the ellipse is constant. So if you kind of look at it right here, it's like, hey, from our focus, aka foci is plural of focus. So from our foci there to any point on our graph, and if you add those up together, so if you take these together, right, they're actually going to go ahead and they're going to add up to our major axis amount. Now, we're going to get back to that in just a second, so I'm actually going to go ahead and erase those for right now. But just as a heads up, these are part of the things that we're going to talk about. So the major thing is that we're going to go ahead and we're going to be talking about our major axis. And the major axis is actually just the part in between the focus, but for right now I want to talk about the entire length. And that we're also going to go ahead and talk about our minor axis going from there. So if we kind of take this back a little bit, I should actually only highlight between our focus right there. Okay, so FYI, your major axis is going from your foci, focus to focus, and then your minor axis goes all the way across. Now you can go ahead, you can stop to read this for a bit. You should kind of note here a little bit is that your two endpoints of the minor axis are the vertices, and the endpoints of the minor axis, that should say the 2 points of the major. It's kind of, sorry that this says minor, I just realized that, right? Of the major axis are the vertices, and the endpoints of the minor axis are the co-vertices. We'll kind of get to all that just a little bit. I just want you to go ahead and kind of graph for a bit here. All right, so when we're thinking about our ellipses, we're going to have our equations that we're going to use. You can see them down here. Is that we have our x squared plus y squared over our a value. X squared over our a value plus y squared over our b value equals 1. And then when we move it, we of course use those h and k values. And if you notice here, they always equal 1. That's kind of a key thing that we're going to use here. So our a value is actually going to be, I'll use pink here, right? So our a value is going to be the distance from, oops, I wanted highlighter pink. The distance from the center all the way, right on the x-axis all the way across. So it's going to be our a value. And then this is our a amount. And then we also go ahead and we have our b amount on our y-axis. So that's where our a and b come to. We're going to come back to a little bit more of that just in a second. All right, but when we're graphing, those are the things that we want to know. Okay, so our number one here is that we have 4x squared plus 9y squared minus 24x plus 36y plus 36 equals 0. Whew, quite a mouthful. But we're going to transform the ellipse into into the standard form and then graph. So right now it's all jumbled up. We got to kind of turn it around so that this is something that we can graph. First things first is we're going to group our x's together and our y's together and move any constant. So I'm going to minus this 36 because it's a constant to get it over to the other side. I'm going to put our x's together. So we're going to have 4x squared minus 24x. And then I'm going to have those y's together. So plus 9y squared plus 36y is equal to a negative 36. Okay, so we're starting to kind of look like our standard form, but we definitely have some more work to do here. Step number 2 is actually to go ahead and factor out your coefficients out of x and y. So I'm going to start with factoring out our 4. So we have 4 times x squared minus 6x. Now, here's the key. Leave a space plus 9 times y squared plus 4y. Leave a space equals negative 36. Now the reason we left a space there is because we're actually going to complete the square. And as a reminder, when you complete the square, you add negative b over 2 squared, aka that is negative 6 over 2 there. Actually, this kind of gets a little bit, we can do this in our heads. Too much of that writing there. So negative 6 over 2 is 3, 3 squared is 9. Okay, so we're adding 9, but as a heads up, we didn't just add 9 to this. We added 4 times 9, right? 4 times 9. So we actually added 36. So I'm going to add 36 to the other side of our equation. Because if you do something to one side, you have to do it to the other. All right, other side here, we're going to go ahead and we're going to take half of 4. So that's 2. 2 squared is 4. So plus 4, but as a reminder, we didn't just add 4, we added 9 times 4 to this side. So we went ahead and we added 36. Okay, now it's time to factor, the whole reason that we did this. So let's get this black pen back here. So we have 4 times x minus 3 squared plus 9 times y plus 2 squared is equal to, we add all these up together, and we get a positive 36. Now we're not quite in standard form because we need this last number here, and this needs to equal 1 in order for this to be a number that we want, right? So we're going to go ahead and divide by 36, divide this by 36, and divide by 36. So when we reduce our fractions, we get x minus 3 squared over 9 plus y plus 2 squared over 4 is equal to 36 divided by 36 is 1. Okay, now we're in standard form, and now we can look at all the things that we need to. So we know that our center is at the point 3, negative 2, and we know that our a value is equal to the square root of 9, which is 3, and we know our b value is equal to the square root of 4, which is 2. All right, so using that piece of information, we're going to go ahead and graph this. So we're going to find our center by going 3, negative 2. Here's our center down here. And our a value says that we go over 3 in both directions. And our b value says we go up 2 in both directions. Okay, now that we have this lovely, our lovely points here, I'm just finding a nice thing that I can graph with. We're going to go ahead and use our pencil to go through our points as best you can. And mine didn't quite pop in a nice curve, so hopefully I can get that going here. There we go. Kind of an ellipse on. Let's see if I can get this. Not quite. That's okay. We don't need it perfect. Again, just kind of going through your points as best you can there on that. All right, so that's graphing from our standard form. All right, so pretty much straightforward, finding your center and then using your a and b values to graph from there. Now, finding your standard form, as we just found out, does get a little bit complicated, but just remind yourself you're going to go ahead and use those completing the square skills that you all have because you've all solved some quadratics before, so you're just going to be using those skills to get it down to the standard form that we have right here. Okay, so now let's go ahead and let's look at this ellipse that we have right here. All right, so we're going to go ahead and find our center first. So our center is at the point negative 4, 6. Okay, so we're halfway there with finding our, oh, sorry, I think that's negative 3. Didn't quite count my boxes. There we go, negative 3. Negative 3, 6, just double checking. Yeah, negative 3, that comes down there. Okay, and then the distance that we have here, so our a value is that we are going over 1, 2, 3, 4, 5, 6, 7. So our a value is going to go ahead and be 7. And we also know that our b value here is going to be 3. So this is 7 and 3. All right, so using all of this, now let's go ahead and write our equation. So we have that x plus 3 squared over our a value squared, which is 49, plus y minus 6 squared over our b value squared, which is 9, is equal to 1. Our vertices are going to be at the major axis ends here, so we're going to go ahead and say that our vertices are at the points 4, 6, sorry, I'm having trouble with 4, 6, and also negative 10, 6. And then our co-vertices are going to go ahead and be at our minor axis, so right here and here. So we have the points negative 3, 3, and negative 3, 9 for those. Okay, so it's time to go ahead and find our foci. So in order to find our foci, I actually want to scroll back up to the top here, and again, you can kind of read all this through. But remember what we said before is that the distance between, actually kind of going back here, right? So these added up together, this sum. So this sum plus this sum is going to go ahead and equal this amount that we have here. All right, so when we're looking at that in general, and we actually go ahead and we, from our foci, go up to the midpoint that we have up here with our minor axis, what we're saying is that, right, this plus this is going to go ahead and equal the whole thing. But those two segments are actually equal to each other, right? That this segment is equal to this segment. Therefore, we have this value right here is this A value is equal to this value here. Sorry, I couldn't quite see that with my highlighter. I'm going to do that again. Is that this value that we have here is also equal to this value. So we can also go back and kind of label this with an A value. So our question is like, hey, where is this point? Well, we have a right triangle and we have two of our sides. So what we can say here is that we can say that this mystery amount that we have down here, right, is b squared plus our mystery amount squared is equal to a squared. And then you can solve from here is that our mystery amount is equal to, mystery amount squared is equal to a squared minus b squared. Take your square root, and we get that our mystery amount is equal to the square root of a squared minus b squared, right? So you're just kind of using your Pythagorean theorem that you have here. So going back down here in order to find our foci is that we're actually going to go ahead and use, right? We know that wherever our foci is that if we have this triangle, we know that this value is 3. And then we're looking at, hey, where's this foci that we're going to find here? We also know that this value is 7. That hypotenuse value is 7. So we're finding our mystery leg here that we have. So we're going to go ahead and say that our mystery amount is equal to 49 minus 9. Sorry, I should say squared. So our mystery amount is equal to the square root of 40, which is equal to 2 square root 10. All right, so our foci, right? So our foci are going to be the distance of 2 square root 10 from our center that we have here. So our center is going to be -3 plus 2 square root 10, and then so that amount over and then up, which is 6, and then also -3 minus 2 square root 10, comma 6. So that's how you go ahead and find your foci for your